Now let us extend the previous problem to some bit. Now we have seen the binary numbers which have to be divisible by 3. Now I can even say 4. The number has to be divisible by 4. We have already seen that if it is the problem is about divisible by 3, we have 3 states. The problem is about divisible by 2, if we have 2 states. If the problem is divisible by n, we have n states. But in this particular case, the problem is divisible by 4. Therefore, I think we should have 4 states. I am not going to go in direct method. We shall use the shortcut which I had discussed. What is the shortcut? First write down all the states. What are the states? How many states? 4 states. Q0, Q1, Q2, Q3. What does each state represent? This state represents the set of all strings which are divisible by 4 or which when divided by 4 gives a remainder of 0, remainder 1, remainder 2, remainder 3. Okay, this is the start state and the input is 0, 1. Therefore, column has to be 0, 1. So, what is the shortcut I told you? Just write Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3. Done. So this is how it can be constructed. Even if you can convert it to a diagram and you can cross verify it, right? So I will leave that as an exercise to you. Now let's just extend this same method for ternary numbers. Ternary numbers means the base is going to be 0, 1, 2, and now let us say the number has to be divisible by 4 itself. The number has to be divisible by 4. So instead of going with the ordinary method, you can choose this method. Here the final state is Q0. Now the divisible number is divisible by 4 and the sigma is 0, 1, 2, which means they have given you ternary numbers and they are asking you the same question. You can follow the same method. How many states? 4 states. Q0, Q1, Q2, Q3, and input is 0, 1, 2, right? So how should you write it? Directly Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3. Final state and initial state are Q0. So it is nothing but set of all ternary strings. This is the DFA for set of all ternary strings which when divided by 4 are giving a remainder of 0, or set of all ternary strings which gives a remainder of 0 when divided by 4. So if you didn't understand or if you want the proof that this one is working correct, how can I prove that this is right? I actually got this with practice. I observed this sequence and I got it. There is no such proof, but let us say we can cross verify, cross check the answer. Now I am going to construct a minimal DFA which accepts set of all ternary strings, which means the input alphabet is 0, 1, 2, set of all ternary strings which when divided by 4 gives a remainder of 0. Okay, so I am going to draw the ordinary DFA. How many states will be there in the DFA? There will be 4 states. Why? Because the problem is about divisible by 4. So let us write like this: Q0, Q1, Q2, Q3, and the numbers are 0, 1, 2, the ternary numbers, right? So when I take the ternary numbers, what are the possible inputs? Inputs are 0, 1, 2. Initially I will be in Q0, I might get 0. If I get a 0, it is simply 0, and if I divide it with 4, the remainder has to be 0 itself. Therefore, Q0 on 0 is going to produce a remainder of 0. So I am going to be here. Now, if I am in Q0 and if I see 1, it is nothing but the final number is 1. If I divide with 4, the remainder is going to be 1. Therefore, 1 is going to produce a remainder of 1 itself. Now, if I am in Q0 and if I see 2, the number is 2 itself, and if I divide with 4, the remainder is 2 itself. Therefore on 2 I'll be going here. Q0 is complete. Why? Because on 0, 1 and 2 we have given the transitions. Now you just cross verify here. See this, Q0 on 0 is going to Q0, Q0 on 0 is going to Q0, and Q0 on 1 is going to Q1, Q0 on 1 is going to Q1, and Q0 on 2 is going to Q2, Q0 on 2 is going to Q2. Now let us take Q1. How did I reach Q1? On seeing 1. Okay, and now if after seeing a 1, if I see a 0, what is this base 4 number, base 3 number? This base 3 number is nothing but 3. How? Take 1, multiply with 3 and you add 0. The final answer is going to be 3, which means 1 0 in ternary is going to be 3 in decimal. Therefore the remainder when divided by 4 is 3. So Q1 on 0 is going to be Q3. Q1 on 0 is going to Q3. Now again I might even see 1. I have seen 1 and I reached Q1. Now I am in Q1, and if I see a 1, this entire number in base 3 is going to be 4 in base 10. How? Take 1, multiply with 3 and add 1. That is nothing but 4. So if I divide 4 with 4, the remainder is going to be 0. Therefore I go back. Q1 on 1 is going to Q0, which is Q0. Fine. And on Q1 you can even see 2, which means I have reached Q1 by seeing 1, and now if I see a 2, it is nothing but 1 followed by 2. In ternary this is 3 into 1 plus 2, which is 5. So it has to be 5. So when I divide it with 4, the remainder is 1. Now let's see Q2. See, Q0 is done, Q1 is done, and now we are going to see Q2. So how did we reach Q2? We have reached Q2 by seeing all these strings, which will give a remainder of 2 when divided by 4. So what is the smallest such string? It is nothing but 2. See, from initial state, if I see 2, I am in Q2. Let us say I am in Q2, right, by seeing 2. Now if I see a 0, what does it mean? It means that base 3 is equal to actually 2 into 3 plus 0, which is 6. So 6 when divided by 4 is going to give you a remainder of 2. Therefore on seeing a 0, I will be in 2 only, because the remainder is going to be 2. See this, now Q2 on 0 is going to be on Q2 only. Now if I am in Q2, I will see a 1. So after seeing 2, I might see a 1. So what does it mean? Then it is 2 into 3 plus 1, which is equal to 7. So 7 when divided by 4 will give a remainder of 3. Therefore on 1 I will be going to 3. Fine. Now if in Q2, which means I have seen 2, if I see a 2, then it is going to be 2 into 3 plus 2. 2 into 3 plus 2, which is nothing but 8, right? So 8 when divided by 4 is going to give a remainder of 0. Therefore on seeing 2, I have to go to Q0. Check it. Q2 on seeing 2, I have to go to Q2. Now let's talk about Q3. How did we reach Q3? By seeing some string which will lead us there. Let us say I am in Q1. How can I reach the Q3? So one is on seeing 1 and on 0. So on seeing 1 0, I have reached Q3. 1 0, I reached Q3. Now in Q3, if I see a 0, what is it going to be? It is going to be you can think of this one. This is nothing but 3 into 3 plus 0, which is 9. 9 when divided by 4 is going to give you remainder of 1. Therefore Q3 on 0 is going to give us, go to 1, Q1. Q3 on 0 is going to go to Q1. Next, let us say you are in Q3, which means you have seen 1 0. Now if you see a 1 on it, it is going to be, this entire thing is 3, and 3 into 3 plus 1, which is 10. So 10 when divided by 4 is going to give you a remainder of 2. Therefore on 1 it is going to be Q2. Q3 on 1 it is going to be Q2. Why? Because I got a result of 10. 10 when divided by 4 is going to give me a remainder of 2. Fine. And now Q3, which means 1 0 on seeing 2. This entire thing is 3. So it is going to be 3 into 3 plus 2. So it is going to be 11. 11 when divided by 4 is going to give me a remainder of 3. Therefore Q3 on seeing a 2 is going to remain here. Q3 on seeing a 2 is going to remain here. Right? So if you look at this, this method actually works. Writing down all these states without drawing the actual diagram actually works. So you can use this method. So this question can be extended to any level. For example, they will say some n-ary number, some base k number, some base k number, okay, which means the alphabet will be 0, 1, 2, 3, so on, k minus 1, and they might ask you what if it has to be divisible, this string has to be divisible by, let us say, m. Then simply you have m states, q0, q1, q2, so on, qm minus 1, and number of rows will be k minus 1, 0, 1, 2, 3, k minus 1. So number of states will be m. Right? So in place of this alphabet, they can give any number system, binary, ternary, unary, anything, and in place of this number which is 4, they can give you n. In general, for such questions, it is going to be number of states is going to be the number which is divisible. Right?